Hello, everybody. It's Thursday, which means it's time for Things on Thursdays, which is my mostly weekly live stream where we're going to look at using Redis and Redis-like concepts. So maybe some of the data structures you've seen in previous streams. We built a bloom filter using LEDs in the Raspberry Pi. And we've also started a new sort of project in the last couple of weeks using Raspberry Pi Pico, which is what we're going to continue with today. So I was off last week. We had a team meetup in Austin in Texas. So it was nice to go out and meet the team. So the rest of the people that you see on stream, some of them I've worked with them for multiple years and never actually met them in person before. So that was great. So I'm back this week with the Pi Pico project. And what I'm going to do is quickly run through where we got to in the previous stream and sort of look at what we're going to try and achieve today, which hopefully is go from fake data into Redis to real data into Redis, and then start to think about what we want to do with it. And yeah, once we've done that, we'll sort of see where this goes in subsequent weeks. My basic aim is to connect a bunch of sensors to the Raspberry Pi Pico and probably get multiple of those going, some of which can be inputs, so things like temperature and humidity or light sensors or a button, and some can be outputs. So let's quickly just go through what we've got here, and I will share my desktop. And so what we've been working with here is the Raspberry Pi Pico family of devices. These are really, really basic. They're not like the regular Raspberry Pi 3 and 4 that you might have seen. They are more like Arduinos. They don't have an operating system. They're a microcontroller. And the way that we've been programming these is using MicroPython, so a language that presents pretty much the same as Python. It's got pretty good tooling support. We're able to code in VS Code and push code down to the device and see the device console in VS Code, which is great because, as you can see, these devices don't really have any meaningful output built in. They're all about the things that you can connect to these pins down the side. So they're all about the expansion things and controlling real world items. So I'm using a Raspberry Pi Pico W. The W means it has a Wi-Fi chip built in. And what that means is that it can connect to a network and at a very, very low level, move things around on a network. So what we're doing is I've created a Redis stack instance in the cloud. So that's Redis plus some extra capabilities. We're going to be using probably the JSON and the search capabilities on this project. And I've been writing code for this device that for the moment just pushes an incrementing sequence of numbers into a Redis stream just to show that we can get something that's really, really basic to do this. So that's the hardware that we've started with. In order to make attaching random sensors a lot easier to these things, I have got one of these, what's called a Grove starter kit. So Grove is like a standard for attaching sensors to devices. And this starter kit's great because it comes with a shield, so a thing that you put on top of the Pi Pico. And once you have that on there, you can then just plug sensors in without doing any further soldering. And it also comes with some outputs. So there's it's hard to see up there, but there's a LED display and there's a temperature humidity sensor, which I hope to use today. There's a light sensor, a button, and some other outputs like a buzzer. So, in future streams, we'll see if we can get at least one of these devices putting data into Redis and then another one reacting to it. So that's what we've got. When we left it last time, I had the Pico sort of in, let's just remove that a minute so we can see it's bigger. I had the Pico in this state, which is how they ship. So it's flat. There's no what's called headers, so pins that might stick up here to push things onto. So if you wanted to attach a sensor to this, you're going to have to solder it. So what I did as homework in between streams is you can get these strips of header pins. They push onto the device kind of like this. And then to make a connection, you have to solder all 20 of these points at the top and make sure that you've done it right. Then you have to do it again on the other side. You can actually buy something called a Pico W H, and the H means it's got these headers pre-attached. And those are a little bit hard to get in the supply chain at the minute, so I wasn't able to get those, so I had to do the soldering myself. So what does that mean? It means that we now have some hardware that isn't flat anymore, and we can connect things to it. So if I share this again, I can show it, but I took a picture of it to make it a bit easier. So it looks a bit like this now. So the Pi Pico is on the top there, or the Pi Pico W is on the top there. That's a USB cable that's providing power. It's also the data cable for how we get stuff, code onto the device. And now we have this Grove Shield from Seed Studios. And what that does is it enables us to use standard cabling to plug in sensors that have a standard sort of cable receiver. And they provide example software in MicroPython for how to interact with these sensors. So what we're going to try and do today is smash together what I had before, which is random numbers going into Redis with temperature and humidity data, and then start to think about what we might want to do with that. So let's get rid of that. So in the real world, it looks a bit like this. So this is the completed artifact with the sensor hanging off. This is a temperature humidity sensor. It's got a bit of a shield on there, I guess, to make sure it gets proper ambient temperature and not just direct sunlight's on it. And we can plug lots of different things into this shield now. We've got it. So we'll start with this one. We've got a lot of other things as well. As I said, the kit itself comes with like this really nice display that we'll probably use at some point to show some data from Redis. And then there's some sensors. There's things to control real world objects. There's a relay here for controlling higher power things or just making a nice clicky noise. Relays do that. And there's a sort of turnable potentiometer type knob here for a more analog experience. So something that isn't on or off, but might have a value between 0.0 and 1.0, depending on how far you've turned it. And so on. So what we'll do is just quickly recap where we got to with the code, make sure that that's still okay. One of the big things with soldering these devices is that you kind of need to make sure that the device still works afterwards, because you're applying a lot of heat to a very small circuit board. So you don't want to fry it. So I did all of that last night and checked it. So I'm fairly confident it's still working. So let's have a look at what we've got here. So to start with, I've cleaned out my database. So let's turn on auto refresh here in Redis Insight. I've got an empty Redis instance in the cloud. So this is a Redis stack instance. It's got Redis JSON. It's got Redis search. It's got some other capabilities that we won't be using. I might use time series in this project, but it's also got a graph database built in and some extra probabilistic data structures. So the stuff that you see other members of the team talking about on streams. Right now, it's completely empty. There's nothing in there. And if we go look at VS Code here and make this a little bit bigger so it's more readable, then what I've got here is a Python or MicroPython project. And let's just move this so we can see all of the code. It's pretty simple. So this code runs on the Raspberry Pi Pico. It's the only thing that runs on there. There's no operating system. So basically the MicroPython runtime, when the device boots, will just run this code. So that means that this code needs to run continuously, because if we stop, there's nothing to drop back to. There's no operating system. There's no shell. So it's basically a pattern, if you're familiar with Arduino coding, of you set some stuff up and then you pretty much go into a while true loop that just runs forever. So that's what we're doing here. And what we've got is just some preamble here that connects to the Wi-Fi. This is example code from Raspberry Pi's site. I've got a secrets file that contains the things that we're not going to share on stream. So my Wi-Fi password and my Redis credentials to the cloud. And once we've got that network connection, we are going to connect to Redis. And to do that, we use a Redis client or SDK. For MicroPython, things are a little bit different. So normally we would like pip install a client or npm install it if you're in the Node world, or have it as a dependency if you're using Java and Maven. For the MicroPython here, there isn't really any sort of package management equivalent and so forth. So I found this Pico Redis client out here it was on GitHub. In the previous stream, I showed where I got it from. I've actually reached out to the person who maintained it to see if they'd be interested in chatting about it. So we'll see how that goes. And basically, this implements part of the Redis protocol, which we've talked about on previous streams, which is a string-based, pretty human-readable protocol that goes over sockets to a Redis server. So I'm using that as the client. If you're familiar with Redis Pi, then it looks a bit similar to that. So we get this R, which is an instance of the client, and we connect it to a host and a port. This client didn't have a constructor that uses a password, and Redis in the cloud requires a password for kind of obvious security reasons. So what we did was then immediately use the Redis auth command to log in. And having done that, all this code does is it basically starts a counter at 0 every time the board boots up. And then we add that value into a Redis stream. So I give it a key of Pico project : incoming. Star means Redis, you figure out the stream ID. And this is really handy in this case because the Pico doesn't have a real-time clock. So we don't know what time it is necessarily without some additional hardware or software help. So what we're doing here is saying to Redis, you just assign the time that this event happens as the time that this command runs on the server. So Redis will do that. We'll get a millisecond precision timestamp there. And the rest of this is what sort of name value data do I want to store? So I'm calling this device ID 1. It's the first Pico device in this project. And then for the data, I'm just stringifying that number. We get a value back from Redis, which is the ID or the timestamp that it's assigned to this entry. Print that out, have a sleep for a little bit. So simulate doing some work, or in the case of a polling sensor like temperature, humidity, you only want it to update every now and then. And then we increment that number so that next time we get a different value. So what we should see here is a couple of things. I've got the board connected to the Mac here. It's just a USB data lead, and it's charging the board, providing power and data. And I have a VS Code plugin that we covered in the previous stream that is handling connecting to that board. And what we see here, the sort of triple chevron, is the Python REPL. So I can basically do Python things in here, and you'll get back. That's actually running on the Pi Pico board. So what this plugin also allows me to do is move my project onto the board and run it. So once the project's on the board, if I power cycle the board, it will automatically run the project. I can do all of that from here without having to unplug it. So if I do all commands here and do upload project, what we should see is it's uploaded anything that changed. It's rebooting. Our code's running now. We're connecting to the Wi-Fi. It's going to take it a few seconds because these aren't the fastest things. So let's let it connect to the Wi-Fi. There we go. And these numbers that we see here now are timestamps that it's getting back from Redis in the cloud. So it's putting values into the stream in the cloud and getting timestamps back. So we have got now something that, here we go. We have a stream here. And if I change this to auto refresh in Redis Insight, what you'll see is new values are appearing, and here's my device ID. That's always going to be 1 because we set that to be a constant. And the data value is going to increment because every time around the loop, we told it to add 1. So right now we've got a sort of satellite type thing going on. This Pi Pico is connected to the Wi-Fi. It's telling us I'm alive and I can count to whatever number it is. And if we Control-C this over here, it stops, and you can see I've got the MicroPython REPL on Raspberry Pi Pico, etc. And if I then tell this to go again, what we'll see is it reboots the board for me. And what we'll see when it boots back up and connects to the Wi-Fi, I've found sometimes you have to do this a couple of times. So that's, oh, maybe. Here we go. There we go. It's back and it's running. So we rebooted it. And because there's no persistent state on the Pi Pico for what the number is, you'll see here we went from 21 to 0 in our Redis stream. So let's Control C that. That's kind of the state of the project that we have it at the moment. And let's turn these off for a minute so that they're not auto refreshing constantly in the background. So what I want to do is a couple of things. So I want to actually get some real data into Redis off of that sensor that we've connected. So we have a temperature humidity sensor, and we'll look at that. And then I also want to look at maybe doing something with that data. So let's just swap over to doing a little bit of drawing here. So what we've got at the moment looks something like, excuse my drawing. We have the little Pi Pico device here, and this is device 1. And it is talking to the cloud. And in the cloud, we've got a Redis instance. So we'll just assume that the only thing in the cloud is Redis. And what we've got in Redis is a stream at our key. So this is our incoming data. And then we've got, this is basically pushing new values into that every couple of seconds right now. So we've essentially got a sort of ping type mechanism of it's just pinging increasing numbers into there. So what I want to do with this is, as we move this project forward over the coming weeks, is a couple of things. We want to, and hopefully that's today's thing, attach a temperature humidity sensor onto here, so we can replace that sort of dummy data with, real data. And then hopefully in a future one, we can attach a light sensor to this, and maybe something else like a button. I am not entirely sure yet how many of these different sensors I can attach at the same time to this shield before I need to do this, which I also want to do, which is add a second device. So our second device could have different sensors on it, or our second device could, for example, be receiving data from Redis and showing it on some sort of local display. So the use case that I'm thinking of going with would be one that I've actually worked with before, which is imagine we are operating some sort of smart hotel building, and we have in each room, we have something that looks a bit like this going on. So we have a device that can gather information from the room. So climate information, how light is it, which could tell us maybe are the curtains open, how warm is it, what the humidity's like, the button we could have for like a sort of housekeeping call button or something. And then we have other sensors in this kit like motion. So what's commonly known as a PIR sensor. So that could detect if someone's moving around in the room. So we could gather all of this information, push it up to the cloud. And then the other sensor that we could maybe have, again, perhaps in each room or the other device, could be more of an output. So this one here could be mostly an output. It could be the wall thermostat that's got a display on it. Or it could be some sort of general purpose display of, okay, we've registered your request for housekeeping. We'll update you when someone's coming. So what I want to do is manage all of that data in Redis. And imagine that we had each of these sensors per room. So if we had like a 300 room hotel, we would have this pair of things here times 300. So quite a lot of things. And what I want to do is manage all of that so that we have displays and inputs. And we are likely going to need up here, sort of either in the cloud or somewhere, some sort of processing that's reading from this stream and outputting things to other Redis data types. So updating other things. So the stream is kind of like a source of truth sequence of events that happen. And then up here, we have some processing that does some other things. One of the things it's probably going to need to do is dereference sensor numbers. So like 1, 2, whatever, to room numbers. So sensors 1 and 2 might be in room 301. Sensor N might be in room 499. So we might need that map there. You might ask, well, okay, why don't you just put that information over on the sensors and have them push it into the stream? Part of the reason I don't want to do that, or why don't we have a stream that the sensors write to that's specific to the room that they're in? Part of the reason I don't want to do that is when I did this sort of commercially for reals, what you find quickly is you want as little as possible information about the rest of the world on the sensor device, because they break, they get damaged by housekeeping or guests. You have to replace them or upgrade them. And the easiest way to provision these things is just give them a singular ID number and then have a map inside your cloud-based software that understands where in your building or your enterprise or whatever it is that sensor is located. So what I'm trying to do is keep that really, really simple. And also because these network links sort of here and here, they may actually be either time or currency unit expensive. So it might take the device a while to talk over them. It might use a lot of power on the device, which if you battery powering it reduces the battery life between charges. And they may also be like over an LTE network or some sort of cell network. So they might cost you money. So we don't want to push any more information than is necessary out of the devices. So we'll keep the devices really simple. It's an ID and whatever data it is. And the ones that show things, we'll basically send it what it needs to know when it needs to know it. So we'll figure out how we're going to do that. What I'm thinking for how to manage this blue component here, the thing that reads the stream and does something with it, is that we'll probably have a Node.js application just so it's a counterpoint to the Python running on the sensors. And that Node.js application will probably do something with Redis JSON, because I know I want to store something about the state of each room. So not really each sensor, each room, because like the entity in my sort of business model that we're dealing with here is rooms, not sensors. Sensors happen to be in rooms. But I don't really know at this point, that question mark, I don't really know what the structure of that data is going to be. So JSON documents seem to be a good fit for that. I can update them atomically with Redis JSON. I can keep counters in them and increment the counter without having to go fetch the value. And I can also then do a sort of, this is a terrible magnifying glass, but I can do search operations over them. So if I wanted to ask Redis something like, hey, find me all the rooms where the temperature is between this temperature and that temperature at the minute, or find me all the rooms where we had occupancy or the motion sensor triggered in the last few minutes, or find me all the rooms where it is brighter than a certain light threshold. Redis search is going to be able to do that for us over Redis JSON documents. So those seem to be solid choices, given that I don't fully know what my application is going to do yet, because we're kind of building this week on week as we go. So yeah, that's kind of a plan for where we're headed. I will get rid of the sketch thing here because it actually burns quite a lot of resources. And we can start taking a look at how we take this code here that really just is a counter and turn it into something better. So these sensors and this the shield that I've got come from Seed Studios. It's this kit here. One of the great things about this is that they have demos and example projects and stuff to get you up and running. So we should be able to take their example code and what we've got already and hopefully replace those counter numbers with actual real data coming into Redis. So let's see about this. So they've got a project here for detecting temperature and humidity with the sensor that they provide, so the one that I showed connected to the Pi there. They're actually using their OLED display to display the values from the sensor. We don't want to do that right now. We just want to send those to Redis. So we have got some example code here, which is great because it makes life a lot easier. And this example code does a couple of things. So it sets up the OLED screen that we're not interested in at the minute. So we don't kind of need this stuff here. What we do need is this. So we need a temperature and a humidity sensor. And they actually told us, I think, up here, which port to connect it to on the shield. So this is where the Grove stuff comes in really handy because it has, let's see if we can get them. These cables here, which have standard plugs on the end, we can just plug things into the shield, plug things into the sensor. So in order to connect the sensor, I don't have to keep getting the soldering iron out, which is great for projects where you are sort of planning something out and just trying things. It's also great for education because you don't have to waste time on heating up a very hot thing and risking getting it wrong. So I've got the sensor connected. It says to D18. That is on this shield, it's one of these plugs. It actually says D18. And if you know a bit about how Raspberry Pis work, the shield connects to all of the Pi's GPIO ports with the headers that we soldered on. And it basically maps to D18 will map to some of those GPIOs. And the software example here is going to deal with that for us. So we want something that's connected to port 18 on the shield. And we're going to need this DHT11 module. This is something that Seed provide. It's here on their GitLab. So we don't need to worry about how that works. That just deals with opening up the pins and talking to the sensor and reading information from it. So we're going to treat that sort of as a thing that we don't need to care too much about and stick to the application level. So I've been ahead and got this file from them and I have put it in the project. So I'm going to rip off their code here. And there's my DHT11 file that I just copied from them. Again, there's no real package management here in MicroPython. So we are just copying things into the project. So up here now, I'm going to need to grab everything from DHT11. And once we've connected to the Wi-Fi, and we've got a network connection, we should probably set up the temperature humidity sensor. So let's look at that. So we need to do that. And then we don't need this counter anymore. And what we need to do here is send temperature and humidity data to a Redis stream. So we'll replace this value here with something else. So let's call that to do. And we'll not call it data anymore. We'll call it temp and, or actually, let's call it T and like save ourselves a few characters of network bandwidth because it all adds up with these little devices. And then we'll call the other field H and we have to figure out where we're getting that from as well. And while we're at it, let's shorten device ID to ID. So once we've figured it out, we are going to send to Redis a command that says, add a new entry to the stream, Pico project, incoming. Give it a timestamp ID yourself because we don't have a clock here on this device. So that's helping us out. And we're going to record that it came from ID 1, and we're going to pass in a temperature and a humidity value that we just basically need to figure out. And then down here, we don't need to increment this anymore because that doesn't exist. Then for real, we would probably not do this every 2 seconds. So temperature and humidity in a room don't change that fast. We probably report this like every 15, 20 minutes, something like that, half an hour. I am not going to do anything with that right now because right here on stream, we want some sort of snappy response. So we'll see it going round and round and round. Okay, so we've got all of those. We've got to do something here to talk to the temperature humidity sensor. Our Redis code is already established. We know that works. So back to the demo here. So we need, this sets up a temperature and humidity sensor on the D18 port, which is where we've plugged it in. So I'll take this bit, but I'll give it a better name. So we'll call it temp humidity sensor equals that. So that will basically establish connection to the sensor for us. And then how do we use this? It looks like, their code looks like my code pattern-wise, because with these devices, you have to run in some sort of infinite loop, because once it stops running, the device is going to sit there doing absolutely nothing because there's no operating system to fall back to. There's no other tasks to do. So what we've got here is a while loop, and it looks like they've got a function inside there called read temp and humid, and it returns a temperature and a humidity. So that looks useful. So that's all of the setup that we need to do, I think. So what we need to do now is read the temperature and humidity data from the sensor. Try that. And we'll call it humidity. And I called my sensor something a bit more meaningful. So temp humidity sensor. That should give us 2 values. So now what I can do is remove these to-dos and do the temperature and replace this with the humidity. And then it might be a good idea to also put those on the console for a moment. So in case anything goes wrong, we can see what's happening. I'm not really sure what scale we're going to get temperature in. It might be Celsius, it might be Fahrenheit. Humidity, I would expect to be like a percentage or something like that. So that might be everything we need. Let's go back and have a look. It looks like it because this stuff here is to do with the OLED, the output device that we're not using on this sensor yet. We'll get that out and use it in the future stream. And then they're sleeping every half a second and updating. So they're reading this sensor quite aggressively, which to me says that me reading it every 2 seconds, so a quarter of the time, is going to be absolutely fine. Okay. So we've saved all of that. So let's see what gives with our database. So in here, we've got the old data. So Redis is, it doesn't enforce a schema in these streams. So you'll notice here, I've got device ID and data as my 2 fields. And I've changed the code here to have ID, T, and H. Redis doesn't actually care. It will mix and match those 2 sorts of stream values quite happily. So we can probably see that if I go to the command line and zoom in a tiny bit. There we go. So if I did something like X add, what's the key name? Pico project incoming, and I said star, you make me the ID, and I said name Simon. I get a value back here. So that's the new value that was added. And then if we hit refresh on this, what you'll see is that this entry only has a Simon value. The visualization tool here shows every possible value that's ever been added to the stream. But the reality of what was added to the stream is just name and Simon. These other two fields aren't there as nulls. They just don't exist. So if we did xrange Pico project incoming, I think something like, let's try this. I think I can just put this ID in twice to basically say, get me that ID. Okay. So if we ask the underlying Redis commands without the visualization, what's in that stream entry, it's just name and Simon and nothing else. So you don't have, your stream schema can evolve over the course of your lifetime of your application without having to like delete the stream or change a schema definition somewhere, because there isn't one of those. Obviously, what you do need is for your application to then be able to cope with whatever types of payload are in the stream. So I'm going to go ahead and blow away this entire stream for now, just so that we have hopefully some clean data in there when we are working with it. And I will get rid of the CLI and turn on auto refresh there so we can see if this happens. Right, so we've made some changes over here. We've got code that hopefully adds the thing to the stream. And let's see what happens if we do upload project. So it's resetting the board. Hopefully it will reconnect and things will start to happen. We'll see. What I found is sometimes you do have to manually click connect. No, it's not happy with that. So let's see what happens if we do this again. Please connect your device. Okay. I'm just going to pull the device out and reconnect it. As you probably know, modern MacBooks don't have many ports. So sometimes when you're doing a lot of USB stuff, like with the iPad, it seems to get confused. So now we're connected. Let's just make sure we are okay. Yep, we got something. So what we should be able to do now is connect to that and hopefully, oops, all commands, upload project, see how that goes. So I wonder if this is not running because it claims I've got some sort of error here. So what is going on here? Bracket not closed. Really? This is one of the issues with. So why are you not happy with that? We've got string temperature. Oh, I see why. I've got a colon there. That should be a comma. That is why. So I'm a little bit used to working with node-redis, where you can pass in a JavaScript object to these things. And in Redis Pi, you can pass in a Redis dictionary. A Python dictionary. Here in the Pico Redis, it is much closer to the actual wire protocol. So we just pass it in a sequence of strings. So I've got a colon here because I'm so used to working with name, value, object things, not a sequence of strings. So hopefully that's cleared the red there that I should have seen before. And if we now do all commands upload project, let's see if it actually runs it. So now we're back connecting to Wi-Fi. So yeah, it's running the code. We don't have any errors. Next question is, do we have temperature readings once we've connected to the Wi-Fi? And yes, we do. Look at that. So, wow. So here, each of these is a stream entry, a timestamp that's come from Redis. And these were the values that were sent. 23.5 is the temperature, 65 is the relative humidity. So it looks like this is in Celsius because it's, yeah, feels about right for here in my office. And now what we should be able to do when we go here is we have a stream that's appeared in Redis. So it's recreated that. I was saying about there being no schemas. One of the other cool things about Redis is if you add something to a data structure that doesn't exist, a key that doesn't exist, it generally creates it for you. So you don't need code to handle that. So here we've got Pico project incoming. It created that for us. If I turn on the auto refresh here, what we can see is it's dumping data into the stream every couple of seconds from the device. So it's now reading the temperature and the humidity, which, you know, over a 2-second gap don't change all that much in my office. I don't know if I can like heat it up I'll put my finger on the sensor for a minute and see if that helps. It's got a shield on it though, so may not. Oh, there we go. It's going up. So it's gone from 23.9 to 24.4. We're getting warmer, 24.6, 24.9. So I am able to affect the sensor by touching it. So we've now got a single sensor, which is a sort of polling type sensor, putting data into our database. So this all looks good. So I think what I'm going to do is bank this in GitHub and stop this from running, because otherwise it's literally going to run forever and just fill up the database. How we manage and control the number of entries in this stream and hence the memory usage of it is another thing that we'll need to consider in this project, because right now we've just got a big pile of data that goes into the stream and nothing's reading from it yet, and nothing is trimming it or removing entries from it. So right now, a little bit of a sort of runaway data structure, but that's okay for now. This stream is only 2K. Redis actually compacts and optimizes these things pretty well, especially when you get lots of entries that are basically the same. It can compact those for us. And if you're interested in learning how that sort of stuff works, then we have a course at Redis University that's literally called Redis Streams. It also uses Python, and it will show you how that works. I would also recommend following Savannah on our Twitch and YouTube channels, as she's doing streams programming on Tuesdays. So yeah, we've got our data coming in here now, which is great. So the next question is, what do we actually want to do with it? So in my sort of architecture sketch, I was thinking I wanted to read each value from the stream and update an entity that represents a room. So I need a couple of things for that. I need some entities that represent rooms, and I need a thing that can read from the stream. And the entity that represents rooms needs to dereference these sensor IDs to, okay, well, what room is the sensor in? So I'll worry about that later. What I was going to do now was kind of switch gears from the Python project here, but I will just bank it in GitHub first. So let's do that. So Raspberry Pi Pico Redis, yep. Adds temperature humidity code. So if you wanted to follow along with this, I have this in GitHub, and I think I have it somewhere over here. Yeah, so it's here in GitHub. I'll stick that in the chat, and if you want to follow along with it, then feel free to use this code for anything you like. It's a MIT license, so you can do that. So here's the URL that you can find it at. Obviously, you're going to need the hardware that I've got in order to use this, but it might just be a good source of reference code and patterns for Redis. And as we go along, I'm going to update this README. So we'll add the link to this video from this episode today, and also the other things that I've used and the things that you need. So I'll try and keep it up to date. Again, if you find anything wrong with it, please send me a pull request. I would be very interested in that. So, okay, we've kind of banked that. We can close that up. And what I was going to do next was work with node-redis and see if we can build something that reads this stream. So let's have a look at that. I'm also just going to unplug the Raspberry Pi so it doesn't keep trying to connect to my VS Code when we're not doing a Pico project. So I'll reorganize this repo later so it's got a folder for all the Python and a folder for all the Node. But for now, we'll just make a new project to call it Pico Project Stream Reader or something for now. No, I don't like that. Let's do it. Pico Project Stream Reader. We've got an empty folder, nothing in it. I want to do a node project, so let's npm init that. And we'll go with some fairly sane defaults. And we'll go with, yeah, why not index.js. Add that later. And we'll right. So we've basically got everything we need. Not going to upgrade npm right now. So we've got a package.json. We better create an index.js as well. We're going to need that. I'm going to need to talk to Redis. So I'm going to do npm install Redis. That will give me node-redis, which is a Redis client that understands streams and JSON documents and all of the things in Redis stack. So let's just have some water here. So we've got the basics of a project here. So let's open VS Code with it. And I really should change this to 2 spaces by default, but anyway. So empty project, what we need to do is connect to Redis at the location in the cloud that we have and pull some data from it or from the stream. So I am actually not going to write this code from scratch. I am going to do what you should do and go look for some example code. So in node-redis here in GitHub, there is an examples folder, and this is sort of a living examples folder. We really encourage and enjoy receiving pull requests for this. So if you're doing something with node-redis and you notice that there isn't an example for it, we would love for you to submit one, or equally if you think an existing example could be done better. So I am going to need a stream consumer, so something that reads from a stream. And we are pretty much going to use the majority of this code. And we're going to kind of adapt it as we go along. But for today, we're just going to get a basic stream read going, and we'll worry about complexities later. So let's just take all of this lot and we'll see what it does and connect it to our Redis. So that first up, we have to create a client, and this is how we connect to Redis. So we create a node-redis client, and I am going to connect using a Redis URL that we will make up here. And a Redis URL is like a standard format way of connecting to a Redis instance. And once we've connected to it, we need to tell it where we want it to start reading the stream from. So 0-0 is the lowest possible ID in a stream, the first thing that can be in it. So for now, we'll tell it, yeah, whenever you start up, read from the start. Obviously, this isn't great long-term because it needs to remember where it got up to and restart from there if it is reset for some reason or if it fails. But we'll not worry too much about that for today. We just want to get the mechanic going. So then this is basically going to sit in a while forever option. We're going to run the xread command, which is the Redis command for reading from a stream. Here in node-redis, because of the way that blocking works in Node and the way it's async, we have to basically tell node-redis we want to use what's called an isolated connection. So we're going to use a connection that blocks for running this xread command, and the client will then use other connections for other commands so we can get other things done whilst we're potentially waiting for things to arrive in the stream. So when we pass this in, we need to give it some configuration. We need to tell it what key the stream is we're reading from and what ID. And if you notice, this is an array, because in a single xread command, we could read from multiple streams, but we've only got one here today. So we only need an array with one thing in it. And then we can tell it some extra things. How many messages or entries do we want out of the stream at a time? So we'll leave that as 1. And how long do we want it to block in the case where there aren't any entries in the stream, or there aren't any new entries in the stream compared to the last one that we've seen? So yeah, we can leave those as they are. So we need to change this. Our key is Pico project incoming, and there's some handy stuff in Insight here. I can hit this button and copy that, and then just paste it straight into my project, which saves me doing some typing. And basically, once we've read something, we'll then get a response object. And what this response object looks like is this. So we get a name entry that tells us which stream it came from, because we could be reading from multiple. So this whole thing's an array, because if we read from multiple, we'll get multiple copies of this back. We're only doing one, so we can expect an array with one thing. And then we'll get this messages array containing however many messages we asked for, if there were any. And then for each message, we'll get the ID and then the body of it, which is the name value pairs. So it'll look a bit like that. So we'll just log that out for the minute. And then what we do to basically say, oh, I want the next message along, is we grab this ID here of the message that we just received, and we feed it back into the current ID variable and feed it back into the next xread call. So we're basically saying, to start with, give me any message whose ID is greater than 00, or give me the next message whose ID is greater than 00. And then once we've got the ID of that message, we keep feeding it back into here and say, oh, give me the next message whose ID is greater than the one that we've just processed. So this mechanic from the example does exactly what we want. And if nothing happens after the blocking, so we've caught up with it, it's just going to print no new stream entries and basically just go back to the top of the loop, start another blocking read, wait another 5 seconds, see if anything turns up, and repeat forever. So I've got code here that should just dump out these messages. I've got a Redis URL that I need to create here. So let's do that. I need to do Redis : / and then it's username. I'm using the default user because I've not set up ACL access control users in the cloud. So I've just got a Redis instance with a single password, a single host and port. I don't have individual named users in there. So what I need is we'll do Redis password, and then we'll do make it something like that. And then we need to do Redis host. So that'll be the host name, and then Redis port, that'll be the port that we're operating on, and we'll just end with a slash for good measure. So our Redis URL is going to look something like that. We've got 3 values now that we need to go find. So let's do we'll get those from process.env. So we'll get them from environment variables, and we'll use an environment variable called basically the same thing as what we're looking for. So we want host, port, and password. That's host, here's a port, and here is password. So yeah, those things I'm going to set in the in the shell off stream so that we don't mess up and expose our cloud database. And then hopefully it's going to work. So what I will do here is disappear off onto the other screen a second and just set those things. So let's do that. So let's all talk amongst ourselves while we set some secrets. But basically, I'm connecting this to the same Redis instance that Insight is connected to, and which also has the Raspberry Pi connected to it. So, okay, we are back here at Pico Project Stream Reader. I should maybe use a .env module for this at some point and put them in a .env file so I don't have to keep setting this up in every new shell. But let's see what happens if we go ahead and run this. What happens is Simon forgot to define a start target in here, so we'll just reuse this one. Run the index file whenever that's started. So hopefully this will connect to Redis and start reading through that stream. And it should be pretty fast because we didn't put any, like, there's no meaningful work in here for each stream entry. So we're not sitting around doing nothing. We're just logging them and then immediately asking it for the next one. And what we'll see in the stream is there's a few entries in here. There's 44 in here already. So let's see what happens when we run this, and hopefully it connects to Redis and works. Oh, it doesn't. Cannot use import statements outside a module. This is another thing that I fall for every time. So we need to set type module in our package.json. You'll also notice I'm using things like top level await. So you need a newer version of Node. Let's see what version I'm using. 16.5.1. Hopefully that's good enough. Right, here we go. Yep, so it connected and it's running through that stream. So it's now reading everything that the Raspberry Pi put in there. You can see that we get these objects back as shown in the demo code. And what's happening now is it got up to this one, and this was the last entry added. So there's no new stream entries available. We've basically processed the stream. So what does that mean? People that watch me talking about streams will know that I do this every time, but it bears repeating. We have read the stream with xread. That hasn't changed the status of the stream. So multiple different consumers could read this stream. The values are still here. You know, Redis Insight isn't out of date here. It's showing what's in the stream. Reading it doesn't delete it. So we need a separate strategy later for what to do when we're finished with some of this data and how we want to age it out of Redis. But that is a problem for another day. So what I'm going to do is leave the node code running here. And then we are going to get rid of VS Code here. And I am going to start the other project again. So let's leave the node code running, and we'll go to look at the Pico project. And we'll open that up in VS Code. And what I'm going to do now is I don't need to plug it back in because the Pico doesn't depend on the laptop for anything. I could take this device and plug it into like a phone battery charger pack and throw it somewhere in my office, not connected to the laptop at all. And it will connect to Redis on the Wi-Fi and start putting data in the stream. It's connected to the laptop here, mostly show it so I can mess with the code and also show you the terminal output. So I'm plugging it back in now, and then hopefully what we'll see is that it starts generating, there we go, it's connecting to Wi-Fi. It starts generating data. And when it starts generating it, the node code will start reading it. And then the Redis stream is acting as a buffer in between. So here we go, it's generating data. And now I'm getting that new data into my node code. So we've gone from having a device that was just essentially pinging numbers to Redis, meaningless sequence of numbers. So sort of Sputnik type era satellite. It's like, I'm here, I'm here, I'm here. And now it's connected to a sensor using the Grove shield and the Grove wiring. That means I can change the sensors more easily. And it's talking through this Redis instance here. So you can see the data updating here as things get added. And then we have some node code that is nothing to do with the Raspberry Pi or Python or knows nothing about where this stuff came from that's starting to process this data. So that's kind of my objective for today's stream. So what I'm going to do is kind of close things up there, and I'll update the GitHub repo and add this node code and all of that before the next stream in this sequence, which is going to be in 2 weeks' time because I'm away again next week. So in a couple of weeks, what I hope to look at is working with getting this data and some other types of Redis key, so JSON documents, to start to build up a picture of what's going on in each room in our building. So we'll probably add another sensor to the Pi. We'll maybe go with the light sensor because that's kind of a fun one to work with. And again, I can cover it with a cup and remove it, and we can simulate different times a day. And then we'll look at how to take this stream of messages and store it in a JSON document per room. And then we'll be looking at how to search over those for things like find me the rooms that are currently in darkness. So we could assume that someone's sleeping. If it's daytime and the room's in darkness, they might be sleeping, or they might have just left the curtains closed and gone out, in which case we might need another sensor to determine if they're really in the room. So we might need a PIR sensor, at which point we can then start to combine information from these sensors. So we'll look at that as the next sort of stream of work, and then we'll go on to look at how to output data from this system back to a device that's got this little LED OLED screen on it, so we can start to show some things back to the ultimate user. And if you want to keep up with what we're doing, so we have developer.redis.com/Redis Live is our streaming schedule, so you can see what's coming up. This is me here today. Actually, I'm back later today along with some of the other members of the team, and we'll be doing Office University hours. Those are actually held on our Discord server, which you can join at the URL below. And our Discord server is a great place to talk about all things Redis. We have an IoT channel where I'm posting about this project, but I'm also really interested in what projects you're doing. So please do come talk to us. And yeah, if you want to continue following this, then follow us on the Twitch channel and also subscribe to us on YouTube. Generally, these streams go out on both of those things, so whichever one you prefer. But yeah, that was it for today. So I think that was quite a productive stream. We got some stuff done. We've got real world data from an actual sensor that seems to respond when you put the finger on it and make it hotter. And I've now got a streaming database going that is still right now filling up with data. So I better just unplug the Raspberry Pi there and stop that. Because if I leave it going, I'll just fill up my Redis instance because we haven't dealt with trimming the data stream yet. But that's a problem for a future stream. So I'll be back in 2 weeks. And for those of us who want to come to Redis University office hours, I'll see you later as those on Discord. And then tomorrow, we're also back with another live stream where we look at weekly questions that came up on Discord and sort of answer them and give some insights and talk about those. So if you're interested in that, that's also on the schedule. And go get yourself in Discord and ask a question. It's not too late to be included in this week's show if we think your question is of general use to the community, and then we'll cover it on the stream. Right. thanks very much, everybody. We'll see you next time. Take care.